Hey, this is Mr. Ward, and here's a video key for the exit ticket 15.1 for geometry. And just a couple questions to consider. We have this one here. So to remind you, if you haven't gotten to chapter 3, there's information here for you. So if two triangles have three congruent sides, we call that side, 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 then those triangles are congruent. If two triangles are congruent, then all parts of the triangles are congruent. As well, this stands CPCTC stands for congruent parts of corresponding parts of congruent triangles are congruent. So sometimes we say kapakataka. So corresponding parts of congruent triangles are congruent. So you'll need a definition of the angle bisector for this one. So we've been given some information. We've been given the information that AC is congruent to BC. So I've marked those as congruent. We've also been told that AD is congruent to BD. So and then we're asked, does ray CD bisect ACB, angle ACB? Well, to do that, we've got to prove that this angle and this angle are congruent. If we want to do that, we're going to need to prove that these triangles are congruent. Do we have enough information? Well, we got these sides are congruent. We got these sides are congruent. We have no information about these angles, so we can't use side, angle, side. I've given you the hint that side, side, side is the thing. So let's see if we can prove that CD is congruent to itself. We can totally do that because of the reflexive property. Things are congruent to themselves. So here we go. Okay. So after, not letting me type. Oh, I know totally why it's not letting me type. I am still in the, I'm not in the actual do now version. I'm in the edit version, but that's okay. So here's what you need to get for this. First, there's the reflexive property. So we can prove now that, so reflexive, okay, so first thing we can do is we can prove that CD is congruent to itself. So CD is congruent, squiggly line, to CD. And because of that, we can prove side, side, side. Okay. Once we've proved side, 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 we can prove that triangle CAD, so triangle CAD is congruent to triangle CBD. Okay, so that's congruent. And once we've proven that those two are congruent, now we can also prove that angle CAD is congruent to angle BCD. Okay, and the reason for that is kapakataka. So corresponding parts of congruent triangles are congruent. We'll demonstrate that angle ACD is congruent to angle BCD. Okay, so we can prove that this angle is congruent to this angle. And the reason we can prove that is that they are corresponding parts of congruent triangles and therefore are congruent. Now, by definition of a bisector, a bisector divides an angle into two congruent angles. So we can now prove that ray CD is an angle bisector by that. Okay, we have two triangles here. And it says here, so here's the information you need to remember. If two triangles have two congruent sides and the angle between those sides, we call that the included angle, is also congruent, then the triangles are congruent. So we call that side, angle, side. That means two sides are congruent and the angle in between. Now you also need to know what a median is. A median is a segment that goes from the vertex of a triangle, like there, to the midpoint of the opposite side. And the reflexive property, I'll remind you, says things are congruent to themselves. So here's the information. So we've been given that AD is congruent to CD again. Okay. And we've been told that ADB, so ADB here, is congruent to angle CDB. Okay, so now we're asked, is DB the median to AC? To do that, we've got to prove that these two segments are congruent because we got to prove that B is the midpoint. Okay. If the way we don't have any information about this angle or this angle, we know this side and this side are congruent. We know this angle is congruent to this angle. And here's the other piece we can get from the diagram. DB is congruent to itself. Okay, once again, reflexive for the win. Okay, things are congruent to themselves. Okay, so now we have side, angle, side. Okay, side, angle, side comes in now that we've proven that we can prove that DB is congruent to itself because now we have side, angle, side, side, angle, side. And at that point, we can go on to prove that AB is congruent to CB. Okay, so I'll make a little squiggle there and a little squiggle there to indicate that those are congruent. So that's by Kappa-Conica, corresponding parts. Oh, no, that's not supposed to be like that. Foop. Corresponding parts of congruent triangles are congruent. Okay, so if you've proven the triangles are congruent, every part of that triangle is congruent. So these two segments are congruent, and then we just have to do the definition of a median. If those two are congruent, then B is the midpoint, and this line does go from a vertex to a midpoint. So we're good to go on that one. All right, I hope that helped.